Okay, so we want to talk a little bit about partitions and file systems. So let's start. And you can see there's about 30 slides. I'm going to try to go through it rather quickly, but please bring up the slides as you go through this. There'll be some links on here that I refer to that I will suggest that you go watch and look at some external content, which I'm not going to do as I video this, but that you definitely want to take a look at. So a partition is just a logical division of your hard drive. Where you go buy a hard drive, let's say 500 gigabytes, and you want to divide it up. You can't divide it physically, of course, so we're going to logically divide it. That's the idea of a partition. The reason for doing that might be several. You want to put data in different locations for flexibility, scalability, administration. Maybe you want to do a dual boot system, Linux and Windows side by side. Maybe you want to separate your system files from your user files. Why would you ever want to do that? Well, it's possible that you fill up your disk space with user files and you don't want your system to just die, because that will happen, or could happen, if you just put all of your files in one. If you put all your files in one partition, as soon as that partition fills up, you can't use it anymore. So that would be nice to break user files that might be created by a user from system level files required by the system. So that could be useful. Upgrading or reformatting is easier when your personal files are stored on a separate partition. If you need to ever reinstall your operating system, that might be useful. Limit your data growth. So maybe I have users on my system that are working with, they think they need to save every little thing on their machine, and maybe I don't want them to. Maybe they're dealing with some huge movie files. Or I shouldn't say I don't want them to, but I don't want them to use more space than we actually have. So that might be another reason. Limit data growth. Okay, so there's lots of reasons for doing partitioning. Now, in Linux, you have to have at least one partition, at least one logical division of your hard drive in order to install the file system. And we've learned that is root, so at least the root file system has to be on one partition. A couple terms here. The verb mount or mounting is the action of connecting a file system or partition to a particular point in the root file system. So for example, you plug in a USB stick. It's actually assigned, or it's mounted or connected to your root file system. In Windows, you might have an A drive or a B drive or a C drive, all of which point to different file systems. The idea is the same. Mounting is the act of adding a file system to a particular point in your root file system. Okay, so now we've got an idea maybe of what a partition is. A partition then is a logical division of your hard drive. One of these logical divisions or partitions we're going to call swap. And swap can be useful for helping our systems know what to do when RAM fills up. If RAM fills up because you have too many processes launched, we don't want processes to just start failing. So swap is a special partition on our hard drive that we can send this process data to instead of just failing the process. So as I wrote here, a swap space is a hard disk partition where your computer can swap out data from RAM that isn't being used at the moment and then swap in the data back to RAM when it's again needed. Although it's better never to exceed your RAM, swapping out is better than just having a process fail. So assume again I have 1 gigabyte of RAM on my system. Let's say I launch 10 different processes. You can pick them: Firefox, Chrome, LibreOffice, whatever it might be. Each of those are going to consume a specific amount of RAM. Now let's say that I've maxed out my 1 gigabyte. I try to launch another process. We don't want that process just to fail. So maybe we'll take one of those processes running in the background that I'm not currently working on my LibreOffice document. We'll send that, at least the process instructions, we'll just write them off to our swap space, write them off to disk, rather than just fail, and then we will work on our whatever thing we opened, and then we'll, when we need to go back to LibreOffice, we'll read those instructions back from swap into RAM so that we can actually work on our instruction. So that's what swap space is. The general rule of thumb is to have swap space that is double the size of your RAM if you have less than 1 gigabyte of RAM. Otherwise, the same size as your RAM. Now, I always forget that second part, and so I usually just double whatever my RAM is. I probably double my hard drive space, or I'm sorry, double my swap space. Windows and Mac OS also have their own form of swap files, they call them, where they, instead of a partition, they just have a particular file that they write and perform the same functionality. Swap isn't absolutely critical on newer Linux distros, but it may impact performance if you don't have it. If you don't have it, and then your process fills up, Linux will still try to handle it gracefully, but it might have a little bit more of a delay or lag there. One of the things I forgot to say on the last one is it's better if we have everything in RAM. Every time we swap stuff out, we're going to take a little bit of a performance hit, but on machines today, you don't see that performance hit very much. Okay, so we talked about a special partition called RAM. Okay, when a new disk is inserted, or when we mount something to our file system, it's going to show up in our file system hierarchy under /dev. Most devices, including USB drives and SATA drives, are treated as a SCSI drive and will show up as /dev SDA or /dev SDB or something like that, /dev SD whatever, depending on how many devices you have plugged in. So basically, the first device you plug in, either SCSI or SATA device, will show up as SDA. Second device you plug in will be SDB. Third device, SDC, so forth and so on. Now you might be wondering, what is SATA or SCSI hard drive? Well, really doesn't matter, but for purposes of this class, it really, it's just the way in which they attach, or the form factor, the way that they attach to your hard drive. So you can see that this one has there's a SCSI hard drive, has a SCSI connector there on the back, versus a SATA hard drive. Now this is SATA. We also look at it, has a different type of connector there at the back. We don't really care. They both show up the same on a Linux system. This is part 1. Pause that here.